Hey everybody, this is Mr. Munson. We're in Unit 1, Geometry Unit 1 Foundations. And so in this first unit, we're kind of bringing back some information from previous years, previous classes to kind of bring it to that first level thinking where it's not, hey, it's been 2 years since I've thought about that, Mr. Munson. We're bringing it together because the thoughts and understandings that we have in this first unit are going to catapult us to success in the further units that we're going to that are going to be brand new concepts. So this is concept number 6, angles and angles pairs. Let's get started. All right, so here are some angles for you. And what I want to do is I want to look at these angles and remind ourselves what kind of angles they are. Just by looking at them, I should be able to do it. We're looking at either an acute angle, obtuse angle, straight angle, and right angles. Those are our 4 main names for angles here. And so just even looking at them, I should be able to classify them from that. But what we're going to first do is we're going to measure them. Partly because I want to make sure you know how to use a protractor, right? So you take the protractor in the center, the middle of the protractor goes on the vertex. And so once you have it on the vertex, you line up the protractor. It might be sitting on your desk in this fashion. So you have to kind of line it up so that the ray, one of the rays goes through the bottom of the protractor. Now on my protractor, there's numbers that go from 0 all the way up to 180 here. And then from the other side, it starts at 0 on the other side and it continues to count up this way. Okay, since we're starting on this side, this is where the ray is, we're looking at measuring it in that direction. So we're going to use the numbers on the inside. Now, as I look at that number, this looks like it's a 40-degree angle. Now, from my previous knowledge, I know an angle that is less than 90 degrees is an acute angle. Let's go down and measure the next one. So I line it up on my vertex. So I'm just going to take it and slide it along, and here we are. So again, we're measuring from 0, and it goes all the way over to this angle over here. If I look at my calculations, that looks like about 140 degrees. So I like to draw this arc here and then say 140 degrees. Now, since that's greater than 90, we know that to be obtuse by definition. Now, let me take a look at this one. This one's the best choice, I think, going to be for the 90 degree, and I think it's going to be. Let's check it. Let's put it on the line, and sure enough, that one is the right angle. That's equal to 90 degrees. And so sometimes we recognize that putting a little box in there to represent kind of like a square down the bottom, and that means 90 degrees in all corners of a square, of course. Now let's take a look at this last one. That is still an angle. It's a pretty wide angle. So let's take this, we'll put it on there, and we'll line it up so that it's on 0. And sure enough, when I measure this angle, I'm going to have to start here. It goes from 0 all the way over to 180 degrees. So let's just draw that. And I'm going to draw it from left to right because I'm left-handed. So that's an angle that's opened up 180 degrees. This is called a straight angle for obvious reasons. Now, adjacent angles are angles that share a ray. So these two angles right here are not adjacent. They're very close, but they're not adjacent. However, if they had the same vertex and shared that same wall, then it would be a pair of adjacent angles. So we'll just say that that worked out perfectly, and there it is. So I have this one angle here, and then I have another angle over here. I always think of this when I was a kid. My room was adjacent to my brother's room, who played his music really, really loud. And now my sister, which was down the hallway, we were in the same house. Her room was not adjacent to me. I appreciated that because the music that she liked was not my kind of music. My brother's music was more my style. So I was lucky that we were adjacent to each other so I could listen to his music, and I didn't have to listen to my sister's music. Okay, now let's look at complementary angles. Complementary angles are two angles whose sum is 90 degrees. And so that's an example of them. So if I was looking at an equation, one that had x's and stuff like that in it, and they told me the angles were complementary, then I would set up the equation that the two angles or three angles, whatever it is, in most cases we're talking two angles, their sum, that means they're going to add together, equals equal sign 90 degrees. Remember, math is a language, and so as they talk about it, and we can say it, a lot of times we even speak our equations right into existence. So here's supplementary angle. It says two angles whose sum is 180 degrees. Is an English word for the equal sign. So sum is plus, and so certainly 30 plus 150 equals 180. Now let's take a look at this problem. It says two angles are complementary. This is what I know. They're equal to 90 degrees. Now for a lot of students, they get stuck and they get them mixed up, complementary and supplementary. And this is how I remember it. So here's a number line, right? Here's 90 on the number line, and here's 180 on the number line. And of course, bigger numbers are down there. 90 comes before 180 on the number line, and so does C come in the alphabet before S. So if I'm stuck, I can remember complementary is 90, supplementary is 180. Well, in this case, it's telling me that they're complementary. Now make sure you watch and look at the process here, because I'm going to have you do this one in just a minute, do one like this in a moment with different information. So since they're complementary, I know that their sum is 180 degrees. So I'm going to write that equation. I got 2x plus 5 plus 3x minus 10 equals 90 degrees. Now put me on pause and just check your math. Make sure you're able to do that. And there I have it. Now hopefully you came up with x equals 19. Now it said actually to find each angle. So what I need to do is not just find x, I need to plug it in. So let's do that. Whoops. Oh, come on. Being silly now. Now remember, if you didn't get 9, you can always go back in the video here and see how I did it and compare it. Okay, so all I got to do is take that 19 and plug it back in. So let's evaluate each expression for when x is equal to 19. We'll just write that one, and we'll do that one on our calculator or in our head, depending on which class you're in. And then the other expression is going to be, the other angle is 3 times 19 minus 10. All right, please don't forget to put your degree mark on each one of these. And certainly we can check our math. And as I do this, it should have added up to 100. But this actually ends up to 110. So I've done something with my math. So I'm going to put it on pause and go back and look at that. All right, so it was in the second one. I just did a calculation error. But I did check my answer. I didn't just kind of plug it in and figure it out. I made sure that the two came up with answers that I should have got. All right, now it's time for you to do this one. Read it carefully. Do the same process. Of course, we're talking supplementary in this case. All right, put me on pause and come back and check your work. All right, I hope you got 83 degrees and 107 degrees, and I checked that, and they add, darn it, if that doesn't add up to 190, I don't know what does, and should have added up to 180, so I better go back and check my work again. All right, that makes more sense now, 79 and 101. So I made a mistake. You might have caught it earlier when I took the 5 and the 10, negative 10, put it together and got negative 15. And that kind of threw it out. And so I found out by just checking my answer, looking at what the answer was and making sure that it added to 180, I was able to go back and fix it and get it right. Linear pair. Linear pair are two adjacent angles that form a straight line. And this is a good example of it. Now we can make the picture look a little bit more complicated, and it's still all the same. I could draw a line like this. I could add a line that looks like this. And those two angles are still a linear pair. It doesn't matter. They're adjacent, and they form that straight line. Now we want to know that because if I walk into a problem like the one off to the left, I can go, okay, hey, that forms a straight line, so I can write an equation. Since straight lines, straight angles, just like we said at the beginning, is equal to 180 degrees, I can write that those two angles must add together to give me 180 degrees. And so then just by simply solving, subtracting 40 from both sides, I get 140 degrees. Well, let's take this idea of supplementary and apply it to another problem. These two are not a linear pair. They're just simply supplementary. This is what I know, that their sum is equal to 180 degrees, right? So again, we can set up the equation that looks like that. It basically says, the equation is the measure of angle ABC. Look at my notation there. It might be kind of rough to see the angle. The angle symbol is like that. So the measure of angle ABC is equal to the measure of FED, plus those two angles must equal 180 degrees. So I just simply take that information and write an equation for it, substituting in the values for each of those angles. And once I calculate that, I come down and I find that x is equal to 20. Now, it did ask me to find that, but it also asked me to find FED. So I just simply plug that number in to FED, and I can calculate what that angle is. All right, we kind of already have a sense of what a linear pair is. It's two angles that are together. Vertical angles might be a little bit of a struggle for you, but it's no big deal to see them. Vertical angles, if you look at them, they kind of form an X. Okay, so I have these two angles, the blue angle and this angle, and they form an X. That's vertical angles. Okay, so what we find is that angle and that angle are a vertical angle. Now let's take a look at 1 and 2. If you look at 1 and 2, 1 and 2 are not vertical angles. That's that linear pair. They're right next door to each other and they form that straight line. So when you look at the definition for a linear pair, I say a pair of adjacent angles that form a straight line. 1 and 2 is an example of that. Now certainly 3 and 4 are a linear pair, 2 and 3, and so on. Vertical angle pairs would be, an example would be 1 and 3. Another pair would be 2 and 4. Whoops. Okay. So start getting really used to the notation on this so you can get. Now, the one above there at the very top, it says find ABF. ABF is this angle here. And certainly we could write an equation as I have here and solve for it, and I get it to be 140. And that makes sense. Now let's take a look at this next one. Let's suppose I said, hey, that angle there is 50, and I want to find all the other angles. Now I can find this one by adding what to 50 to get to 180, and that's 130. I can set up an equation. I could maybe use a calculator to subtract it from 180. But now let's take a look at something. Suppose I want to know what KBG is. Well, let's cover up some of the information and see what we have here. It's another linear pair. Well, if the 130 is sitting up there, certainly the blue angle is its supplementary, right? So I can subtract it from 180 and get 50. But see, we already knew that. And so what we find from this little disclosure is that vertical angles are congruent. They're same. They're the same measure. So without even chasing over and finding what this blue one is, because the green one's 50, I know that its vertical is. And the same is true about the other pair of vertical angles. If the red angle above is 130, and so is that one. All right, that's it. I'm going to give you some problems to do here at the end. Some almost every one of them have, well, every one of them has to do with this video. So make sure you understand those. Refer back to your notes to make sure you have something. You're not just making guesses. And the questions will pop up for those people who are doing it on my special video. All right, we'll see you next.